All right, welcome back. We're going to talk about why the power rule and the derivative of the exponential function behave the way they do. For the power rule, we're just going to check it for where a power is a positive integer or a non-negative integer. To do that, you need something called the binomial theorem. We'll kind of work it out on our own here. So first of all, let's notice the following. If I have x plus h to the n, that means I have to multiply this x plus h n times against itself. Okay? And what you do, from each of these parentheses, you pick either an x or an h from each one, multiply it together, and you look at all possible ways to do that, and that's what the power is. Now, if you pick only x's from each one, you would pick an x from the first, x from the second, x from the third, and x from the nth one, you would get n x's multiplied together, so x to the n. But you could also do the scenario where you pick one h from and all the rest x's. So a single h and n minus 1 x's. And so you're going to get an h, x to the n minus 1, but I could have picked the h from the first term, or from the second term, or the third, or the nth term. So there are n ways that I could have gotten that term there. Everyone else, so the first term we wrote down is when you pick no h's. The second one is when you pick a single h out of all of them. And everyone else has to have at least 2 h's or more. So it's h squared times a bunch of stuff I don't even want to write out. Okay? Again, if you want to see what all those other terms are, it's fun. It's called the binomial theorem. Anyway, so now we can check the power rule. So here we go. So if we want to do the derivative of x to the n, well, this is the limit as h goes to 0 of x plus h to the n minus x to the n all over h. Okay? So this is the limit as h goes to 0 from what we wrote above, that's x to the n, plus n h x to the n minus 1, plus stuff that at least has h squared terms in it or higher, and then minus x to the n all over h. Okay, so the x to the n's cancel, and so we have an n h x to the n minus 1 plus h squared times a bunch of other stuff all over h. We can divide out an h everywhere. So we get n x to the n minus 1 plus h times a bunch of other stuff. And then, well, the limit now, this h is going to 0, so it doesn't matter what the rest of that crud was. It all dies in the limit, and you just get n x to the n minus 1. And that's what the power rule said. All right? All right, now let's look at the exponential. Remember, we said that the derivative of e to the x is actually e to the x. Now that actually follows really from the definition of e to the x, but we're going to get at this numerically because that's kind of sophisticated. So let me do this. Here is an observation. Suppose I'm going to make a chart here of h going to 0. And over here, I'm going to calculate this limit, h minus 1 all over h. All right? So I've got some values here, 0.01. If I plug that in, I get 1.00501, and then more decimals. If I plug in 001, I get 1.00050. And if I plug in 0001, I get 1.00005 and more decimals. And you can mess around with this, and it's not hard to see that it looks as if the limit as h goes to 0 of e to the h minus 1 all over h is 1. And that is actually true. You can verify it if you have some more advanced techniques. But right now we just have it kind of numerically, that limit is 1. And that's going to be enough for us to do the derivative of e to the x. All right, so using that fact. The derivative of e to the x, by definition, is the limit as h goes to 0. You plug in x plus h, then you subtract off plugging in just x, and then you divide by h. So that's the limit as h goes to 0. I want to factor out an e to the x from everyone on the top, so that leaves e to the h minus 1. Now, this e to the x, you normally think of e to the x as a function, but for the limits purposes, h is actually the variable here. So x is a constant as far as h is concerned. So e to the x is a constant as far as x is concerned. So it pulls outside of the limit, because constants pull outside of limits. All right. Well, this limit we just said was 1. So you get e to the x. And that's why the derivative of e to the x is e to the x. Ciao.